All right, so welcome to Math 213. We're going to do statistics and then geometry. So we were just talking about the vaccine before class, and I did a little research about the Pfizer vaccine. There's 4 or 5 of them out there now. And this graph here shows efficacy rate of the Pfizer vaccine. So the way they run clinical trials usually for something like this is it's usually a double-blind study, which means the people in the study don't know whether they're getting the real vaccine or a fake. And the doctors involved don't know whether the patients have the real vaccine or the fake. That's not revealed until later. And the red graph here is the people who got the placebo starting at the beginning of the trial, and then this one ran for, what would that be, 4 months. And you can see that this is just the accumulation of people who got COVID-19 during the trial. And you can see it rises at a pretty steady rate. Okay? So this is the normal growth rate for COVID if people are moderately cautious. The blue one down here is the graph of COVID cases of the people who got the vaccine. And if we zoom in a little more, can't really get further in, you can see for the first 7 days, there's not much difference between the vaccinated and unvaccinated people. It takes a little while for your body to build up its immunity. But then after that 7 days, all of a sudden, the rate at which vaccinated people get the disease just falls away. And so people rarely get COVID after getting the vaccine. Now, it's not impossible to get it, but after 7 days, there's about a 95% efficacy rate, which means that 5% or less of people that are vaccinated actually get COVID later. And the report went on to talk about that the symptoms they had were far less, and the severity and the risk of death was way far less if one gets the vaccine. So this shows some reasonable evidence that it's probably worth getting the vaccine unless you have a really good medical reason not to get it. This kind of graph here is called a time series graph or a line graph, and we're going to play with these more as the course goes on. And then the other details about this are a little beyond the scope of this class, but I thought that would be an interesting graph to take a look at there. And I hope you will think about getting vaccinated once you have the opportunity. Okay, so over to our course here. So this course is similar to the last couple quarters in the way I have things set up. There's a couple of minor differences that we'll get to later, but I'll talk a little about today. There's going to be a reading assignment, so read the book and tell me about the main topics, similar to before. I have a bunch of videos preloaded from previous quarters in each section, and then there's some activities we'll do together, some homework similar to homework before, and again, activities and homework. I think I might have forgot to post, did I post the calendar? Let's see. Not there. I forgot to post the calendar. Okay, so I have a daily calendar of what I'm going to cover which days. I'll get that posted later today. So it's going to take us for chapter 7, which is on statistics, about 3 weeks to get through it. And then we'll have a test on chapter 7, and then we'll move on. The rest of the quarter will be geometry, and we'll cover 2, maybe 2.5 more chapters. So the plan now is to cover statistics, which we have section 1 about graphs, section 2 about calculations like average. Section 3 is about samples and a thing called the normal distribution, and then we'll have an exam on that. And then we're going to move on to chapter 10, and these sections, like before, are there's a lot of information in them, and it's going to be about 1 section a week. Sometimes we'll do 2 sections in a week, but mostly it's just 1 section a week. and similar reading activities and homework. Excuse me. Oh, and then the big difference that's going to come later is in chapter 10, the homework system that we were using before doesn't have a lot of geometry stuff available. So we're going to try something a little bit different. Khan Academy, which you may have heard of before, has a lot of good geometry stuff. So we're going to switch in chapter 10 to doing a lot of our work in Khan Academy instead of through the Canvas links here. And I'll show you how to do that once we get there. So that means you'll have to sign up for an account with the Khan Academy later, which is free. Okay, smart page. Wrong button. So the topic for the next few weeks is statistics. And this is chapter 7. And just a couple things about statistics, and then we'll jump into section 1. Statistics is just the science of data collection and description and analysis. Now, in this course, since we only have one chapter on it and only a few weeks, we're mostly just going to focus on the description part of statistics, a little tiny bit on the collection, and we don't really have too much time to do analysis, which is like using data to make predictions. But we're going to do a tiny little bit of that. So mostly we're going to do descriptive stuff with a little bit about how data is collected and a tiny little bit of analysis. And often in many degrees that are like science and technology, you take like a year-long sequence in statistics courses, but we only have less than a month on it. So we're just scratching the surface on that. When we're playing with data, so the question is, what is data? And data is just information. The information usually comes from observations or surveys. Or experiments. Like the Pfizer vaccine drug trial was an experiment. Some people got the vaccine and some people didn't, and we looked to see what happened to them after, not knowing who had the vaccine and who didn't. So that's where we have an experiment, and again, people had to volunteer for that, knowing the risks involved, and we're definitely grateful that these kinds of things happen, and we have the advances we do in medicine. Sometimes studies are observational, where we just look to see what happened. Like the beginning part of this whole COVID thing, we were just watching, seeing who got COVID and who didn't, and then trying to figure out when COVID was more dangerous. Like we noticed that there were certain ailments people had prior to getting COVID that it turned out they were more susceptible to death. So that wasn't an experiment. We didn't have any control over the situation. We were just observing what happens. And then other times we just go out and we ask for information from people through surveys. So there's a lot of different ways we get data. Now, once we get data, you can think about data in terms of a spreadsheet. And in a spreadsheet, we have these columns and we have rows. And the columns in the spreadsheet represent variable information that we get. For example, I have a class roster And in my class roster, I have your student number, and I have your name. And let's see, what else do I have in there? I have an email address for you. I have a date of birth, among other things in there. And so each column represents a variable, right? So everybody has a different name, that varies. Everybody has a different email address, that varies. So our columns are the variables. And then the rows are known as cases or units. And so that's each person in the class. Right, so we have student number 1, 2, 3, 4, Beatrice, and Beatrice has an email address, blah, 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 and a date of birth. And then we have another student named Bo, who has some other email address, and so on. And so each row in that spreadsheet is a case. And so a case could be a person, a case could be a thing. There's lots of different things. And then there's the common variables for each one. So that's kind of like the simple idea of data and the places that we get it from. Now, as far as descriptions go, the descriptions kind of depend on the type of data that we collect. So there's two main kinds of variable types. There's categorical, which describes some quality. So examples of quality could be things like name, gender, eye color, anything that describes. Other kinds of variables are quantitative, some kind of number. And a number could be a date of birth, an age, height, anything that we can measure or count. The reason we distinguish them is there's certain kinds of charts and graphs we can make for quantitative data that we can't for categorical, and there's certain calculations we do for quantitative that we can't do for categorical. So for example, with categorical type variables, you can't find the average name or the average gender. What you can do is find out if there's more men than women, or what's the most common eye color. And so things we can find here are what's called the mode. You might remember seeing that in some previous math class. That's the most frequently occurring item or value. And we can also find like a proportion, like maybe 50% of the class is male and 50% is female. So that's like whatever part we find over the total. For quantitative information, we can still do things like modes, proportion, but then we can do like, what's the average date of birth? What's the average age? What's the average height? We can add up numbers and divide. We'll also try and figure out what's the spread of the numbers, and there's a variety of ways to measure that. Most of what we're going to do today is play around with different charts and graphs for categorical and quantitative information. And then next week, we'll worry about these kinds of calculations there. So what we're looking at here in terms of these calculations, this is part of statistics that we call descriptive statistics. So descriptive statistics is taking a big group of information and trying to summarize it a little bit. And so one way we summarize is with calculations like mode, proportion, and average. And then we play with charts. And so there's a bunch of different kinds of charts that we're going to play around with. And so we're going to need some data to do that. So I need you guys to do me a favor, and we'll come back to charts in just a moment. All right, so we have this average person survey. We're just asking for some information about you. It's confidential. So age, gender, hair color, eye color, height in inches, weekly income. So there's a mix of information here. Some of it is what I referred to as quantitative, like an age. Some of it is qualitative or categorical, like gender, hair color, eye color. So this isn't a survey that I could use for any analysis because I'm getting it pretty conveniently from my students. And information is self-reported and not verified in any way. Like, I used to think I was 5'10" until my wife pointed out, there's no way you're that tall. You're like 5'8", Gary. And I measured myself, and sure enough, I'm only 5'8". Weekly income, some people might overestimate, underestimate that. And hours of sleep in a night, there's lots of ways to think about that. Like, you mean the amount of time I'm in deep sleep, the amount of time I'm in bed trying to sleep. So getting information, it can be a little bit tricky sometimes. But I just thought I'd ask some information that, you know, interesting to know about us college students. And the information is achieved in different ways. Now, for example, hair color, people get to type whatever they want. And some people typed things like brown with a capital B. Some people did dark brown, brown with a lowercase b, abbreviation, DK brown. So one question is, after we collect data, how do we deal with it? Dark brown spelled out versus DK brown, are those really the same thing? So once you get a data set, often you have to scrub the data to make it usable after. The only time you really don't have to scrub data is if you had a preset something to choose from. So for example, with gender, I gave the options, but I did give people a chance to put something else in, which does make it more complicated to deal with. So making surveys and collecting that information is a whole nother topic. There's whole courses in just how to do that. And then the question is, will people read this correctly? Because I've had people enter some crazy numbers, like what was one of the ones I asked about here. Hours of TV each day. I've had people type things like 40. Apparently they were thinking per week, or maybe they mistyped 4-0 instead of a 4. I don't know. All right. So we've got some different kinds of information. So we're just going to think about what kinds of graphs we could make with information that we have here. And we're not going to get to all of this today. There's a lot of stuff here. At the moment, so I give this to a few classes a year. So I started giving it in 2018, and at the moment, 116 people have taken it. And I'm in there a few times, probably. So let's start off with, say, eye color. That's probably one of the easiest ones to deal with here. Another thing about playing with data, you never want to edit the original data source in case you make an error. And errors can come in a lot of different ways. Like, I have to make a decision how to deal with, say, the dark brown that's spelled slightly differently, because some computer systems view a capital D different than a lowercase d. And here I clearly have a DK brown, which I'm assuming is dark brown. off black. I have not seen that one before. That's funny. Strawberry blonde, dirty blonde. I had a friend who always thought that was a bad term. Brown, blonde-ish. So we have some things that we have to think about here to deal with. All right, so usually when I have a survey like this and I have the form responses, and an interesting thing, I don't know if you guys have ever played with Google Forms before. Google Forms gives you a few different ways to view your form. So this is my editing version of the form. Earlier you were looking at the view of the form where people take it. And then they have this responses page here where they try to make charts. So here I'm in the summary section. So they try to make some charts for me. So notice they made a gender chart for me. So I would like to figure out how to make my own gender chart. They made a hair color chart based on the raw data, which is kind of weird. Yeah, notice there's a capital B brown and a lowercase b brown and a light brown. So we got to figure out what to do with that. And then there's all kinds of eye colors. We can probably narrow that down. So we're just going to pick a couple of these to work with and then figure out how to make such charts. Some of these charts, like the hours per day for work and TV and school, we'll get to those probably next. Let's see, when am I going to get to those? Oh, I might get to those today, if not next class. All right. So some of these should look familiar to you. These bar charts that are for a lot of the questions, the numerical ones, those are often called histograms instead of a bar chart. And I'll explain the difference between a histogram and a bar chart shortly. But let's go and start with something really easy like the gender. So again, when you make a Google form, you have how many different views of it? 1, 2, 3, 4, or 5 different views. So I have the summary here. I can view the actual questions and then people's response per question, or I can look at individuals and the responses per individual. Or even better, I can dump it all into a spreadsheet that we play around with, which is what we're going to do. So once it's in a spreadsheet, the next thing we want to do is we want to duplicate this tab. So don't make your own copy yet. Just hang out with me for a minute. So I'm going to go duplicate here. I'm going to do a harder one, and then you're going to make an easier one based on that. So what I did is, again, I just made a copy of the original form responses. So I don't want to edit this original tab. I want to edit this one right here whenever I do something. So let's see. I think I'll let you guys do gender in just a minute, but I'm going to go for eye color. So I have to decide how to scrub the eye color here. And I'm going to probably do like replace the blue lowercase with a blue capital, because otherwise the computer will count lowercase blue different from uppercase blue. One easy way to do that is to go to Edit, Find and Replace, and then I want to find any places it sees lowercase blue and replace them with capital blue. And then I can, usually the safe thing to do here is replace them one at a time. So you can just go to Find and then Replace. And if you move this over to the side, it'll show you which one it's working on. I'm going to zoom out a little bit on this. Do I want to change the blue green? Interesting spelling of green. That looks like something I would do. I think I'll skip that one. Jump to the next one. And oh, match case was not there. There we go. And if you feel safe, you could do replace all, but that can, so we have a green, blue, and a blue, green. Got to decide what to do about that. I'm going to leave that for the moment. So find skips to the next one. Oops, I probably should have gone back and done that one. Oh well. Replace, 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 replace. Oh sure, we'll replace, replace. Why not? Apparently I missed a couple. Did I miss a lot? Should have gotten all these the first time. Huh. Didn't seem to do it, did it? Most of them? Okay, now it's finally done. So again, you could have just done a replace all. So I'm going to do that one more time. Brown. And then we're just going to do a replace all on that. On all sheets. Oh. Didn't realize it would do all sheets. There we go. This sheet only. So I don't want to mess with the original sheet. Let's see, Hazel. And there are ways to deal with this when you make the form, but it's a little bit tricky. I'm just going to do one more, we'll call it good. I guess I should do green too. There's probably a bunch of those. All right, so let's say we're happy with those. So then what you do is you highlight all the things you want to make the chart with. So if you haven't made many Google charts, they're actually pretty easy. So let's say that's scrubbed enough. And then I just say, hey, make a chart. And usually I select the title too, and Google will recognize that that's probably the title. Now here it's making a histogram of count of eye color. So it's basically looking at each color and counting how many there are. And I don't want a histogram, I want a pie chart. And let's see, I have blue, green, brown, blue, hazel, and green, and then a bunch of weird ones in there that are small enough it's not even going to mark at the moment, and we're just going to say that's okay. So it's relatively straightforward depending on your data. So since this was a free-form entry, I had to do a little bit of scrubbing, and probably based on this weird section here, I probably should do a little bit more. And then you can edit things by just double-clicking on them. So I can just use eye color there. And then other things you can do under the customize section, which is where I'm at now. You can edit a slice, you can edit general information. Oh, did I switch back? There we go, eye color. You can play with having a legend or not. Since these have the attached labels, I don't think we need a separate legend. And then you can play around with different color slices. So blue is currently blue. Hazel, maybe I could pick different color. And then if there's some that are similar, you can pick similar colors. You can kind of go and play. Like maybe brown should be brown. Is that brown enough? Sure. And green could be green. So you can play around a little bit. All right. So one kind of chart we can definitely make with categorical information is a pie chart. All right, so what I'd like you to do now is to make a copy of this sheet and then make a pie chart of the genders. That one should be pretty straightforward. So for the height in inches, again, I'm just going to take the first 25 of those. And let's see, I think I probably need to do a screenshot. And I'm going to make what's called a dot plot. The book calls it a line plot. I'll explain the difference in the two names and why they're actually the same graph. Just a sec here. So this is what I call a dot plot. It's also known as a line plot, not a line graph. That's different. We'll get to that in a moment. So what a dot plot or a line plot is it's for a set of numerical data like this right here, quantitative, and it's just based on a number line, and it's like a histogram. So with a dot plot or a line plot, the first thing we need is a number line that will allow us to use these numbers here. And then once you have a number line, above each number, you make a mark, usually a dot, sometimes an X, for each number, each time the number occurs. So I'm going to make a mark above a value for each time it occurs. Computer can do this quicker, but this is something that's done a lot with kids because it's something they can easily do on paper. So let's see, it looks like my smallest number here is 52. And what's the largest? 72 maybe? Looks like the largest number I see in there. So maybe I'll start over here. 52, 53, 54, 55, and I'm not going to label everyone. 56, 57, 58, 59, 60, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 70. Oops. 75. And so then I just kind of move down the list, and I think I'll use dots today. So there is a 68, so 5, 6, 7, 8. So I'll put a dot right there, and then a 72. And so you just make a dot, and you just keep stacking them. 69, 64, 70, 62, another 70. Oops, did I put that 70 in the wrong spot? I did. And so on, 67. And I'm not doing a very good job making the dots the same size, but that's supposed to be the goal here. 68, 65. And you want to stack them when they double or triple up at the same size. 60, same height. 69. Here. And so on. So there's software that will automatically do this for you if you put the numbers in. And so then you just keep building up from there. 63. And this gives you an idea of how the data is distributed. Where are there more heights? So this is the beginning of a dot plot. 64, number 70, 63, 72, 67, 52, 72, and 71. So when you have a kind of graph like this, and the two main graphs that show data distribution are this dot plot and another kind of graph. This is similar to a histogram, which we're going to make in the computer in a minute. And a dot plot and a histogram they're kind of like bar charts. So instead of making dots one at a time, I could have just made bars that were 1 high, 2 high, 4 high, 3 high. So there are multiple options in how to make something like this happen. So let's head over to a spreadsheet, and with the first 25 numbers, and then with all of them, we're going to make a histogram, which is like a dot plot. And so I'm just going to highlight height in inches down to the 26th row, which will give me the first 25 heights plus the title. And then from there, I'm going to insert chart. And in this case, Google guessed that I wanted a pie chart, which is not what I want. So just because you can make a chart doesn't mean you should. That's pretty, but not useful. So I am going to go for, I think, so just a regular bar chart isn't useful either. What this does is it plots the numbers it sees in order: 68, 72, 69, 64, 70, and so on. So this really isn't a useful display of data. Again, just because I can make a chart doesn't mean I should. So this one isn't very useful either. I'll explain what a histogram does in a moment. So I'm going to go for a histogram for now. So what histogram does is it groups things together. I'm just going to change the way Google chose to group this. So again, just try this along with me. I'm going to delete that and start over. First, I highlight my data, and I'm just going to highlight the first 26 rows, which gives me the first 25 heights plus the title. And then I'm going to select Insert Chart. If Google doesn't give me a histogram, then I just go to Setup Chart Type and switch from whatever it gave me to the histogram. Next, I'm going to adjust the histogram to be more like that dot plot that I made over here. So I just want it to count individual numbers, like how many 52s were there, how many 60s were there, how many 62s, and so on. So to do that, I have to go mess around with the Customize Histogram section. In a histogram, you group things together, and the groups are called buckets or bins or categories. Google calls them buckets. And it says, hey, what do you want your bucket size to be? Google's automatically picking a bucket size of 5. So it's grouping from 50 to probably 54, and then 55 to 59, 60 to 64, 65 to 69, 70 to 74, and so on. And what I want to do is switch it to every 1. Now, it looks a little bit different than mine just because I had a lot more vertical space above mine. I made my columns rather short. So notice how tall a 1 is here compared to 1 in mine. And I could tweak it to make it look more like that. Let's see, that would probably be the vertical axis. So again, I went into the histogram and I said, hey, let's make the bucket size 1. If you show the dividers, that just puts lines in at every 1. And then I'm just going to adjust the vertical axis to kind of squash this down a little bit. And I'm going to set the maximum to maybe 5. It's a little bit more like what I made. So they have these little rectangles here, 6, even 7 high. Now they're more like little squares almost. So this is a lot like the dot plot. So I have these little rectangles instead of dots. And here the grouping is just by 1 at a time. Now, problem with that, it makes it hard to read along the horizontal axis. And we can always adjust that by just clicking on the graph and expanding it lengthwise so we can see the individual numbers a little bit better. It's got the 0.00 on those, which we can probably do something about. So almost everything is editable on these. It's just a matter of finding the right menu. So maybe horizontal axis. Series. Don't seem to have a place. Oh, grid lines and tick marks maybe. seem to give me a place here to edit those values. That is surprising. All right, if I figure that out later, I'll let you know, or if you figure it out, let me know. Major spacing count. Oh, that's the vertical axis, oops. Oh, I know, horizontal, oh, let's see, where was I? Grid lines, horizontal. That gives me no options. Major ticks. Nope. Interesting. Okay, so not as configurable as I hoped. Microsoft Excel does similar things. They have a few more options, maybe twice as many, which can be kind of overwhelming at first. So I usually like Google Sheets for introducing graphs. Any trouble making a histogram? We'll come back to histograms in a minute. So here I use the histogram feature of the spreadsheet to make something like the dot plot that I made on paper. All right, so let's see, what other graph did I want to make here? Let's make a bar chart. So a bar or column chart, depending on the orientation, you need your data in categories. Now, often qualitative data, categorical data can be put into categories pretty easy, right? Categories like eye color. So this is easy for, say, gender, or eye color. But it's more work for quantitative data, as we just saw. Because with quantitative data, you're most likely going to have to group the data. And so we'll look at that grouping next, but let's work on some basic ones. And then once you make a chart, it usually pops up near where you started highlighting data. And so you have a couple options. You can move it out of the way of the data, but just by clicking once on it to get its attention and clicking again to drag it around. Or you can move it into its own sheet. So that's what I'm going to do with this one right now. Well, so the problem with moving it into its own sheet, then it takes up the whole screen, which means you can't like customize the height and width once you do that. So I think I'm not going to do that for this one. I'm just going to move it out of the way. And dragging them around is a little awkward because you're confined by the screen that you can see. So it's a little bit of a pain. Although you can cut and paste them. That's probably what I should have done next time. So the histogram, since I was playing with the height and the width, I probably don't want that in the new chart, but the eye one, that would be fine in its own sheet. And so then it takes up the whole screen there. Okay, so now I have a new tab for that chart, and otherwise I'm working on the copy. So let's take eye color that I edited just a little bit and play with that for a moment. Let's see, are there any other changes we want to make here? I think I want to combine the blue greens together. Is there really a dark brown versus a brown eye color? I suppose there probably is lots of variation there. I should at least spell this one right. Blue, green, green, blue, blue, gray, blue, green, hazel green, blue, green, brown, green. Okay. All right, so I think I'm just going to fix one more of these, and you could decide to fix these or not to match the others. Make that a capital green and maybe a capital dark. I think I was the only one of those. So we're just going to make a different kind of chart here. So for the eye color, we're going to highlight all of it. A quick way to highlight a long column, if on your keyboard you do Control-Shift down arrow, it will look for the end of that section. And it thinks that section's over because of the blank cell, but if I keep Control-Shift and hit the down arrow a couple of more times, it'll keep looking for the bottom. And so here I can see I have the bottom now. So once that all the data is highlighted, now alternately you could highlight the whole column, but then you run the risk of having stuff down below that you didn't notice. So I don't usually do that. I usually start at the top and Control-Shift down arrow till I think I got to the bottom. If you accidentally go too far to the end of the spreadsheet, then Control-Shift up arrow will take you to the last place there was data. All right, so once I highlight them again, we just push a button. Now here it's doing what's called a histogram, which is a little bit weird for eye color. So we're going to get out of that one. And let's try the count of eye color. So what the computer is going to try and do for us is it's going to say, okay, look for anything. We see a blue at the top, so find all of the other things called blue. We see a hazel, find all of the other things called hazel. Otherwise, we're forced to do this on our own, and there are several ways to do it. And then notice that it's got all the variations here too, like blue-green, dark brown, green-blue, blue-gray, hazel green, and brown-green. And so here, again, it's just a bar chart based on the categories that the computer found, and you could decide to scrub this or not. Things I would do to clean up this particular chart would be to, I don't need to say count of eye color, just eye color I think is sufficient. And I think it's pretty obvious that those are the eye colors, so I really don't need horizontal text title. So I can get rid of that. And then Google sometimes lets you edit the individual colors, format data point. So for example, I could, if I want, play with colors here and pick different colors for each one. What color is hazel? Is that like blue-green or green-brown? Either of you know? Never been sure about that one.
It's like a green-brown, like a light green.
Light
yeah.
green. Okay. Let's see. Let's go with that color there then. And I think I'll leave the others alone. So we can play around with that. And notice it just gives us a count. So 40 people said they had brown eyes, 30-ish people said they had blue eyes, and so on. And then you can just kind of play around with the different customization options that are listed in the Customize menu. So there's, mathematically speaking, that it's not too much different than with a bar chart like this versus a pie chart. Just same information, but presented in a different order. You can modify bar charts to do things like percentages or counts. Notice there's 32 blue, which is 28.1%. So we could modify, if we wanted to, this bar chart, sometimes called a column chart because they're vertical, to include other information like the actual number or the percent if we wanted. Questions on the bar chart? Okay, so let's see, what do we want to play around with next? I think this is a good place to stop the recording, and I think it's probably time for histogram.